In this video, we will look at internationalizing an existing Rust codebase. In particular, the Bionic GPT codebase that you can see on the screen at the moment. There has been an outstanding issue for several months, and I wanted to see if I could implement this using AI coding. Quick bit of background. I have some development experience and know how we would go about implementing internationalization in a Java codebase. But I don't know any Rust. I don't know any of the libraries or frameworks used in this codebase. So first of all, let's have a look at what we actually have implemented. So if we flip over here, so this is now in Spanish. I will show you later on the existing or the current codebase, which shows it in English only. What we've done is automatic switching. So if we go down to settings, and you should be able to see languages. I now have Spanish at the top there. So the changes we've done, pick up the language based on browser settings. We can go through the different screens. I mean, all the translations have been done by AI, and I'm not Spanish speaking, so I'm assuming they are correct. I have actually implemented or attempted to implement this several times without a great deal of success, but each time has actually led me to refine the process and the prompts used, and I'm going to go through that entire process. This final implementation that has worked has taken under 3 hours and has cost around $30 in token costs. I've used Perplexity's deep research right at the very beginning, and we'll go through the full process of what I've done, and then all the coding has actually been undertaken using Claude's latest 3.7 Sonnet model. So let's have a look at the whole process and see where we started. So on the screen now, you can see the full prompt I used within Perplexity, and again, this was under deep research. So I've asked it to review the full code base, and I've given it access to it using another tool called Git ingest, which converts a full GitHub repository into something which is easier or more suitable for a large language model to digest. I've then said fully understand the architecture and the development process. I've pointed it to the contributing.md file, which is on the project. Again, undertake a full review of best practice approaches to implementing i18 in Rust. We ask it to also review what you have produced and then focus on the best way to actually implement it. So I want it to do some research and then actually pick the best way that it thinks it should do. I want it to implement the simplest way, and I only want this to implement browser based. So as mentioned earlier on, I went through several different iterations. It did try and do several different options. One of them was having a switcher functionality in the front end, which allowed you to change language. I didn't actually want that. I want this purely to be based on browser settings. I've also wanted to implement i18n for all the hard-coded web front-end strings. So I don't want anything done in the database. What I actually want it to produce is a detailed technical implementation plan for the required code changes, together with tests required to check. And again, it's on the screen there. I will put a link to this in the description so you can read through this, and down below this is what it produced. So executive summary, understanding i18 in Rust, which is great. It shows different ways of doing it, popular different libraries, so there's more than one library, the language detection methods, so this is what we're going for, but it has actually listed some of the others. We've got the recommended strategy, technical implementation plan together with the libraries. Here we actually have a directory structure, and we go down to quite a lot of detail. So some actual Rust code there, which I'm not familiar with at all. It produces, well, certainly from my perspective, quite a detailed document. Now I took that document and I copied that over to my development environment. So if we just flip over there for a minute now. So here in my development environment, this is our code base. I created a spec directory, and I copied this in tech spec, and this is that document copied directly from Perplexity. So if we just put that into proper view mode, and we can see it's that same document. And from now on, all development and all additional documentation is all done entirely using this plugin here, or extension called Klein, and it's using here, I specified the Claude 3.7 Sonnet model. On the screen now, you can see the prompt I used to start the full process off. So this is being fed down via Klein into Sonnet. So I've said using the tech spec, and I've specified it there. That's the one that we have taken from Perplexity. Break the development down into iterations. For each iteration, create a detailed technical implementation plan together with unit tests. Store each of these in the same directory. Ensure these are detailed enough such that an AI model can use these as the basis for implementing the required i18n functionality into Codebase. We'll run each iteration manually, driven by the developer. Each iteration must have detailed unit tests to cover at least 90% of all code changes. All iterations must pass or must run without any errors and pass all tests. So once I actually ran that, let's just reduce that in size again. If we go back to our code, I actually had these additional files created for me. It looks like I also created an overarching one. So this is a file, but each iteration is created here, and we can have a look at those in a bit more detail. So again, first iteration is all to do with setup and basic infrastructure. So this is our dependencies, this is creating our directory structure. Here's some basic tests as well for different languages, and we go through and we run those. And then for each one of those, if we go back into the Klein extension, and let's go back up to here. Once those iteration technical plans had been finished or had been created, I then instructed Klein to implement iteration 1, and we continued on like that all the way up to iteration 4. And sometimes it had to go back because there were errors that sometimes came up, but by the end of it we actually had some code, or certainly we had some front end in Spanish. Now one thing I did notice, there was only some of the code that had actually been changed. So final pass after the 4th iteration, I just went in and actually asked it to update individual pages to ensure that those had actually been changed, and that was the full process. So we had a functional spec, or in fact a technical spec, which was generated by Perplexity Deep Researcher, which is based on research on the best way to implement i18n in a RUST Codebase. That was then taken across into our development environment, and we used Sonnet 3.7 to then create technical implementation steps for that. And then we just went through and asked Sonnet to implement each one of those. And we went through. I have now checked that code base in. I'm now going to create a pull request and see whether it actually gets accepted in. So hope you found that useful. Thank you very much, and I hope to see you in the next video.